everybody, this is O from CLO Ed TV. Today's video is all about water. Now we're in part 2. Last week I went over part 1, which is how to find clean potable water, and you need a zero water filter. So if you haven't seen that video, definitely check it out after this one. But we're going to cover wastewater treatment a little bit today, and then next week we're going to go over details on each method within wastewater treatment. So without further ado, let's get to it. Allowances made for fair use for purposes such as criticism, comments, news, reporting, teaching, scholarship, and research. Okay, so the first thing we're going to learn today is, where does our sewage go? Let's take a look.
Waste from London's toilets, sinks and gutters is carried away by a network of interconnecting ever larger pipes designed and built by sewage superstar and pioneer Joseph Bazalgette. It all ends up here, a sewage treatment works.
Okay, so this is the sewage treatment facility, and you'll see me pausing the video in between as to stay within the use of commentary and fair use guidelines. The engineer depends on your region. So depending on where you're at in the world is the engineer that has invented or inception of your sewer system.
Is Beckton Sewage Treatment Works in the east of London, and it's Europe's biggest. It was originally part of Joseph Bazalgette's scheme, but I tell you what, sewage treatment has really moved on since his day.
In the 19th century, sewage was simply stored here in tanks, then pumped out to the river at high tide. So you'll be pleased to know today's process is a lot more refined and takes just 4 hours for raw sewage to be clean enough to return to the river.
Every day, this treatment works handles the sewage from 3.4 million Londoners. Now that's an astonishing volume. It equates to 34 Olympic swimming pools every hour.
That's a lot of people.
So how does it treat the byproducts of our late-night beer sessions and trips to the local curry house?
The first process happens here at the inlet works. Using these screens, large lumps like bricks, wood, rags are raked out.
Okay, what's interesting about this filtration system, it gets the big bulk out first. And imagine just some things you've seen people throw, or maybe you've thrown in the sewer. Did you think it would end up here? Who knows?
Collected, these large objects will all be washed and sent to a landfill site nearby.
They've even had half a car here.
Meanwhile, the remaining sewage passes on to the next part of the process into these primary settlement tanks.
Now very basically, it enters at that end and flows relatively slowly this way.
Over the top of each tank is a moving bridge, which has 2 blades to remove solid organic material from the sewage. The top blade skims scum from the surface, while a second submerged blade dredges the heavier settled sludge from the bottom of the tank. All this solid sludge is then sent for further processing.
The remaining sewage then flows down this way towards the secondary biological treatment process.
And here it is. In these tanks, the sewage is mixed in with billions upon billions of bacteria, so all the dissolved materials that still remain can be biodegraded.
Okay, so what's interesting about this process, I'm kind of familiar with this. They're using bacteria to kind of eat away the sludge, and that's kind of like a source of food for the bacteria. So this is pretty interesting. Let's look into it.
And pumping air from below at very high pressures causes the sewage to be saturated with dissolved oxygen, and this accelerates the biological breakdown.
It's brilliant.
Finally, the treated effluent is tested to ensure it's clean enough to go back into the Thames. Meanwhile, remember all of the solids which were skimmed off earlier? They're taken to a processing plant.
All sludges are brought to this filter press where it's dewatered, and the resulting sludge cake is incinerated, and that provides 75% of this entire work's power needs.
Okay, so what's interesting about this particular plant, they actually use the waste as a fuel source, and I think that's pretty cool. All right, so we're going to go ahead and transition over into the next video, which is, in actuality, we're going to look into the NYC sludge sewer system and how they deal with their sludge. We're just going to take a brief snippet of this as we're going to go over this in detail next week. All right, so let's go ahead and see what they have.
Across all 5 boroughs of New York City, an estimated 8.3 million people flush their toilets multiple times a day.
Look at all that crap. It looks like rope.
Everything from fecal matter to Clorox wipes go through the city's elaborate network of sewers, creating 1.3 billion gallons of wastewater per day.
This is the bane of my existence.
This deluge of wastewater travels through some combination of the city's 7,500 miles of sewer pipes, 135,000 storm drains, 96 wastewater pumping stations, and 14 treatment plants to be disposed of. But even with the system's impressive ability to hold, transfer, and treat all of this wastewater, it sometimes gets overwhelmed.
Okay, so just to take a brief notation of that, this is part of the sewer system, and you can get an idea of kind of what these plants have to encounter. So we're just taking a small snippet of that. Now, let's go ahead and transition over into how the actual system works. So in the next clip, we're going to see actually how the sewage system, a basic sewage system, works. All right, so let's go ahead and check that out. I'm going to go ahead and get that queued up. And here we go.
Gravity. It's the defining principle of physics here on Earth. It affects nearly everything in the universe and is precisely 9.80665 meters per second squared at sea level.
Let's cue that over again. All right, here we go. So, here we go.
Gravity. It's the defining principle of physics here on Earth. It affects nearly everything in the universe and is precisely 9.80665 meters per second squared at sea level. It's also how your poop gets from your toilet to the wastewater treatment plant. Sewer systems are wonders of modern infrastructure. Back in the olden days, cities had open sewers where waste flowed through open canals on the streets. Today, we're much more civilized. We transport our waste underground in large pipes. Sewer systems are essential to modern plumbing. Every time you flush a toilet, use a sink, or take a shower, you create liquid waste of varying chemical makeups that has to be transported.
Okay, that's something to think about. So think about all the stuff that you wash down the drain, including bleach and all sorts of stuff ends up in the drain, and you got millions of people doing the same thing.
And treated. You could just flush it into a septic tank, but these tanks require maintenance and come with a host of other issues when integrated en masse.
Oh, by the way, septics are good for private or rural area. If you're off grid, septics are perfect. All they need to do is get pumped when they're full and other things, but we'll get into it.
For modern cities, we have to manage our waste because it stinks, it contains deadly bacteria,
Absolutely.
and it has dangerous chemicals that could affect the environment. You probably know that wastewater gets treated at a wastewater treatment plant, but let's take a look how it gets there. Sewer systems. Urban wastewater systems are needed in densely populated areas so you don't have to deal with your neighbor's waste. In ideal environments, sewer systems are completely gravity-fed, meaning that the pipes slope downward from the source, your toilet, to the wastewater treatment plant. This is done because wastewater has a lot of solids in it, making it harder to pump. Wastewater also has a lot of bacteria and chemicals, and when we push it through turbulent environments like pumps, it can create dangerous and deadly gases like hydrogen sulfide.
Okay, I want to make a brief transition into another video, and what's interesting about this video is it includes, and you'll see in a minute, what happens when those gases get taken over. So check this out. Oh my goodness. That's so scary. Okay, so just to explain that, basically methane is created. Even animals explode like this naturally. So what happens is there's stuff digesting with the enzymes and everything in your body, and it creates a gas, and that gas is actually explosive. So if you're at a manhole, do not, and I repeat, do not throw any flammables, no cigarette butts, no matches, nothing down the drain. All right, let's go ahead and finish up how water systems work. All right. All right, we'll transition over. All right, let's pick it back up.
In an ideal sewer system, pipes from each house or building flow into a sewer main that usually runs alongside a road or underneath one. The sewer main in a large area is usually 3 to 5 feet in diameter, with pipes from each house being about 6 to 12 inches in diameter on average. In every sewer main, there are periodical vertical pipes that meet the ground with manholes. These access points are spaced depending upon the local code and needed just in case a problem arises in the sewer main. Say your toddler has a nasty habit of flushing toys. If they do this enough and the toys make it into the main, there might eventually be a major clog that city workers need to remove.
And on that note, think about what you've seen or what you've actually thrown down the drain.
Sewer mains will flow into progressively larger and larger pipes as they accumulate more and more sewage, until eventually they reach a wastewater treatment plant. Usually, these plants are in low-lying areas to make engineers' jobs of designing sewer systems much easier. However, all of this gravity-fed sewer system talk is the ideal scenario. What happens when your house is below the elevation of the wastewater treatment plant, or if the sewage needs to travel over a hill? You need to pressurize the poop. This is done using grinder pumps or lift stations to pump the sewage up over hills.
Now I want to mention this. These lift pumps are done with diesel fuel, okay? So they need diesel fuel to run. Now, for my solar experts, can a solar system provide enough power to keep our municipal water system going? That's something to think about. So that I want everyone to comment in the comment section below. Do you think renewable energy will be able to replace the power for our municipal water system?
These stations collect sewage from lower elevations and utilize pumps to push it up to the needed height where it can gravity flow from there on out. These pumps are specifically designed to handle the high amount of solids seen in waste like toilet paper and flushable wipes. These pumping locations are usually in places of relatively low elevation due to their nature and will likely have a small building to house the equipment. They're also usually placed far away from human populations as they have a nasty habit of exploding, or at the very least producing dangerous levels of hydrogen sulfide due to the turbulent sewage. Sewer systems at their core are a bunch of sloped piped drains that take your waste from your house to a treatment plant. Occasionally there are pumps, but for the most part, gravity does all of the work.
Okay, very interesting. So we're gonna go ahead and transition to this part of the video. So guys, that is a brief introduction on CLO Education TV on the waste management system. This is just part 2 of my water series. And guys, all the links for the clips that I reviewed and commentated in this video will be in the description below. If you learned something new, share this video out with a friend. And if you would like to support CLO Design and Ed, there is several support links in the description. Also, you can support via CLO Academy on GoFundMe. Okay, so if you would like to support the CLO campaign for the CLO Academy, the link will be in the description. Guys, I hope you have a great day. I really enjoyed you tuning in. Thank you for your time. And guess what? I'll see you on the next video. Peace.